Hello. Hello, and welcome to Mr. Berger's discussion on Ohm's law. So you should have in your notebook used the triangle and come up with the equations for Ohm's law, which I'm going to put up on the screen now. So that's current is equal to voltage divided by resistance. Voltage is equal to current times resistance. And resistance is equal to voltage divided by current. So you should have hopefully come up with those. And make sure you write those in your notebook. You might want to label each of the variables so that you know what they mean. And then you should update your physics gems page with the three variables that you have. Those are, of course, voltage, current, and resistance. So you can do V, I, and R. I'm not going to do those for you right now, but if you want to, stop the video and go ahead and you should go ahead and fill those out, looking back at your notebook to make sure you know the appropriate units for those three variables. Okay, so moving on, I want to go through a couple of examples for you just to make sure that we know how to use it. So the first example has a toaster oven, has a resistance of 12 ohms, and is plugged into a 120 volt outlet. How much current does it draw? So of course, the first thing is we always try to identify what is the variable that we're looking for, and we're looking for current. So I'm going to write that up here, and I'm just going to put a question mark. So current, remember, is the symbol I. Okay, and we're given two pieces of information. We're given that the resistance is 12 ohms. So remember that omega, the Greek letter omega, is what we use for resistance. And then we know that the voltage is 120 volts. Okay, and then we go back and look at our equations, and we see that current is equal to voltage divided by resistance. So we're going to plug in those variables, 120 volts divided by 12 ohms. And this is going to give us 120 divided by 12 is 10 amps, which is the correct measure of the current flowing through this circuit. Okay, so let's go through the next example. A motor in a toy car needs 2 amps of current to run properly. If the car runs on one 1.5 volt battery, what is the motor's resistance? Okay, so again, we're looking for finding the resistance. And we're told that it needs 2 amps, so that's the current is equal to 2 amps. Okay. And we're told that we've got 1.5 volt batteries. Remember, batteries provide the voltage, so that is going to be our voltage is going to be 1.5 volts. Okay, and I'm going to go look at my equations, and I know that resistance is equal to voltage divided by current. So I plug in for my voltage, 1.5. I plug in for my current and get 2. And I go to my trusty calculator and do 1.5 divided by 2. This is going to give me 0.75, and then it's resistance, so it's units of ohms. You might just have to memorize those particular units until you get comfortable with them. Okay, so if you're feeling pretty comfortable right now, you can go ahead and start your practice problems. But if you'd like, and continue through those practice problems until you get to the question on batteries, okay? And then you can go to the video and look for Ohm's law on a series circuit. So you can go ahead and skip ahead. If you want more practice, I'm going to go through a few more examples for you right now. Okay, so this next example, how much voltage is needed to power a 20 ohm resistor with a current of 15 amps? So again, in this case, we're looking for voltage. okay, which is the one we haven't done yet. And we're given the resistance, the ohms, and we're given that the current is 15 amps. Okay, and again, so V in this case is equal to I times R, and that is going to be 15 amps times 20 ohms. Okay, 15 times 2 is 30, so we've got an extra 0. This is going to give us 300 volts for V. Okay, let's work through one more example. If 10 volts of electricity is producing 20 amps of current through a light bulb, what is the resistance? Okay, so again, we're looking for resistance, pretty straightforward. Okay, we know that we're also given the voltage, which is 10 volts, excuse me, and we're given the current as 20 amps. Okay, so resistance is equal to V divided by I. So this is 10 volts divided by 20 amps. And this is going to be resistance of 0.5 ohms. Okay, so here's where I would recommend you stop and work on the practice. You may work on the practice with a partner or a friend, or compare your answers. I would definitely recommend you show your work and practice working through these and making sure you're doing them correctly so that you're not making some silly errors. If you feel comfortable and you get to the questions with the battery, then move on to the series circuit, which is what I'm going to talk about next. Okay, so we're looking at Ohm's law in a series circuit, and really this is no different than what we've just done. We're just putting a few other ideas together to try to practice, but there's not a lot more to this than what I've already been through. So the main idea that you need for a series circuit is that whenever you add a new resistor to that circuit, okay, and a reminder, a series circuit is just a circuit where you have one path for the electricity to flow. If you add an individual resistor, okay, you try to figure out the total resistance by just adding them together. And this plus ... on the end here just means that you can do this for as many resistors as you have. Okay, so let me go through an example using Ohm's law on a circuit. Okay, calculate the current through the circuit. So we've got a 9-volt battery over here. We've got 3 resistors. They might be light bulbs here. And the question asks us to calculate the current. So if we write for Ohm's law, if you remember, our current is going to be equal to our voltage divided by our resistance. So we have to figure out the voltage and the resistance. Now the voltage is fairly straightforward. Okay, the one battery is providing all of the voltage. Okay, a resistance is a little bit more complicated, but not a whole lot. All I'm going to do is I'm going to add up the individual components here. 100 ohms plus 300 ohms plus 50 ohms. Okay, and this is going to be 100 plus 300 is 400 plus 50 is 450 ohms. Okay, and now I just use Ohm's law now to calculate the current. I is equal to the voltage, again 9 volts, divided by 450 ohms. Pardon the handwriting. And again, I'm going to pull up the calculator. So I'm going to take 9, I'm going to divide it by 450 because I can't do that in my head, and I'm going to get 0.02 amps. Okay, 0.02 amps. Okay, definitely recommend that you try that along with me on paper to make sure that you're following what I'm doing. Okay, let's try one more example. Or let's just change the problem a little bit. So remember our ampage is 0.02. So now, how would the current change if we increased the voltage to 18 volts? Okay, so we're going from 9 volts to 18 volts. So we could go through the entire problem again, just like we did, okay? But I'm kind of lazy. So what I'm going to do, let's go back and look at our previous problem. And I noticed that we've got 450 ohms and 9 volts. So the only thing that's changed is the voltage. So what I'm going to do is I'm going to take a look at my current, and I'm going to, again, know that it's voltage, excuse me, divided by resistance. So it's going to be 18 volts divided by 450 ohms. Before I do anything, I can just observe that the voltage doubled. It went from 9 to 18, and our old answer was 0.02. So I would expect if we double the voltage, if we added a second battery, we're going to increase the current by 2. So let's take a look. 18 divided by 450. I'm going to just double check that that's correct in my calculator. 18 divided by 450. It's going to give me 0.04 amps. So all I did here was I got this resistance the same way I got it last time by adding those together. Okay, I think you've got enough now. You should be able to work through the rest of the problems, think about them, go through them carefully, and of course ask questions, lots of them. Thank you very much. Hope this video was helpful.